Today's lesson focuses on how to differentiate between relations and functions, okay? And we're gonna learn how to analyze relations, and relations can be anything from a table to an arrow diagram to a graph to determine whether they are functions. And finally, by the end of this lesson, you're gonna understand what the vertical line test is and how you can use it to your advantage. So a function is just a specific type of relation where every x value produces only one y value, or every input produces only one output. Okay? Some relations, a single input produces more than one output. And we're going to use this example to illustrate that concept. So I've said consider the domain 1, 4, 9, 16 and the range 1, 2, 3, 4 for the two relations below. So for the first one it says is a multiple of. And throughout this unit we've been looking at multiple ways to represent relations. So for this part right here we're going to do it as an arrow diagram, a set of ordered pairs, and a graph. Okay, so if you want to pause the video and try both of these, I'd encourage you to do so. So for our arrow diagram, or our mapping diagram, I'm going to list my four values of my domain in the left-hand column, and I'm going to list my four output or range values in the right-hand column, and I'm going to draw arrows that connect them. Okay? So, and I need to think about the concept is a multiple of. Okay, so 1 is a multiple of 1. It's the only arrow it's going to connect with. 4 is a multiple of 1 and 2. 9 is a multiple of 1 and 3. And 16 is a multiple of 1, 2, and 4. Okay, so there's lots of arrows going on there. If I wanted to write the ordered pairs, well, I don't think I'm going to write all of them, but maybe I'll just do 16. So for example, 16, 1 is an ordered pair, 16, 2 is an ordered pair, 16, 4 is an ordered pair, and obviously I could also have 9, 1, 9, 3, 4, 1, 4, 2, and 1, 1. Okay? But just this is enough. As we start exploring a function or not a function, this will be enough to tell us something important. Finally, if I were to graph this, I'm not going to graph it to scale or anything like that, but I'm going to do my best. So I've got 1, I've got 4, I've got 9, I've got 16, 1, 2, 3, 4. If I were graphing this relationship, it would look something like this. Okay? And again, not perfectly accurate, but it will do the job when we get to this. And hopefully those values are showing up on that video for you. Show the relationship. Okay, over here is the square of. So if I were doing an arrow diagram and trying to show the relationship, again, I would need to put all of my domain values in the left, all my range values in the right. And in this case, 1 is the square of 1, 4 is the square of 2, 9 is the square of 3, 16 is the square of 4. If I were to go ahead and do a set of ordered pairs, well, this one's going to be much simpler. There are only 4 ordered pairs in this relation. And finally, if I were to draw a graph, again, it's not going to be perfectly to scale or anything like that. I'm just writing the 4 values that I want right here. But what I would see is I would only have 4 values there. Okay? Now, let's go back to our definition. A relation where every input or x value has only one output value. Well, on an arrow diagram, what we'll notice is that our 1 has only one output value, but our 4 has 2. Our 9 has 2. Our 16 has 3. So therefore, this is an example where a relation is not a function. Okay? And if you're looking at it for arrow diagrams, notice we're kind of getting that scissor effect, okay? Where one x value has more than one y value, so this is not a function. If we were looking at a set of ordered pairs, all we would need to look for is, if it's not a function, the same x value appearing more than once in our set that has different y values. Okay? And we're going to introduce the idea of a vertical line test soon, but basically for now, what I want you to pay attention to is notice how at certain points on this graph, we have points that are stacked one on top of each other. Okay? And that is a visual sign that one x value has more than one y value, therefore it is not a function. Okay? In contrast, when we look at this relation, where one number is the square of another, each x value only has one y value. Each x value only appears once in our set of ordered pairs. And unlike the graph over here, when I graph this relationship, there is no moment where two values are stacked one on top of each other. Therefore, it is a function. So to test your understanding of what we just looked at, why don't you pause the video and try these two examples. So for this one, again, we need to be comfortable moving between tables, sets of ordered pairs, arrow diagrams, graphs. In terms of an arrow diagram, if we were to turn this into an arrow diagram, 2, 3, 4, 5, and 1, what we would notice is that there is no part where we get that type of scissor effect. Every x value has only one y value. Okay? In the table we can also see that. 2 only has one y value, 3 only has one y value, so on and so forth. And the final way we can kind of confirm that is if I were to graph this out, I would notice that, yes, I have 4 points in a line, but at no point do they stack vertically on top of one another. And therefore, this is a function. Over here, as I look at this table, I notice a problem. The same x value appears twice with different y values. So this is not a function because 3 has more than one y value. If I made an arrow diagram, it would produce that type of scissor effect. And if I produced a graph, 1, 2, 3, what I would notice is that my points right here would stack vertically on top of each other. It only needs to happen once, but this means that this relation is not a function. To finish off this lesson, we're going to consider a couple of graphs. Asking simply, are they functions? So for this first one, if we're trying to consider, does every x value have only one y value, the simplest way to do that is using something called a vertical line test. And all a vertical line test means is that if you ran a vertical line across a graph, would it ever touch the graph in more than one place? In other words, do you ever have multiple x values stacked one on top of each other? And for most of this relation's existence, that it only has one point. But right around here between 1 and 2, if we were to draw a vertical line somewhere around there, it touches the graph or touches the relation at multiple points. And therefore, this is not a function because it fails the vertical line test. Okay? Here, same idea. If we ran a vertical line over this graph, would it ever touch the graph in more than one spot simultaneously? And just a little review, open dots mean that there isn't actually a point there. Closed dots means that there is. So for this one, this actually is a function because the points, for example, at -1 and +1, where we kind of have points stacking on top of one another, one of them is an open dot, one of them is a closed dot. Therefore, this passes the vertical line test, never touches 2 points simultaneously. Therefore, it is a function. So I hope this lesson has helped you to understand how to identify functions from tables, arrow diagrams, ordered pairs, and graphs, and that you have an understanding of how just running a vertical line over a graph could be a helpful tool to use as you're identifying whether relations are functions.